Hello everyone. In this lecture, we will understand why is processing important in IoT. In IoT systems, thousands or millions of sensors continuously generate huge amounts of data like temperature readings, heart rate data, traffic information, and many more. Now, if we do not process this data properly, networks become overloaded. That is, if raw data from all the sensors is sent continuously, it creates heavy traffic in the network. And this leads to congestion, delays, and reduced communication efficiency. And also, the decisions becomes very slow because of this, as without processing, the systems must handle large volumes of unfiltered data. This will increase the response time, which is not suitable for real-time applications like healthcare or traffic controls. And also, the system may fail in critical situations. That is, in emergencies, the delays in processing can cause serious failures like missing a heart attack alert. And proper processing ensures timely and reliable system behavior. Therefore, IoT needs intelligent processing, intelligent and resourceful processing techniques. Why? Because in order to analyze the data quickly, that is, processing will help the helps to filter and interpret data instantly, enabling the real-time insights. And this is crucial for applications like smart homes and industrial automation. And also, this intelligent processing, it is required to reduce the unnecessary data transfer. That is, only important or meaningful data is sent to the cloud, reducing the bandwidth usage. And this saves the cost and improves the network performance. And also, it makes the decisions faster because the processed data allows the systems to act immediately without waiting for remote servers. And this is essential for time-sensitive operations like accident detection. And this improves the system efficiency, where efficient processing reduces the workload, saves the energy, and optimizes the resources. And also, this will make the IoT system more reliable and scalable. Now, before processing the data, we must decide when to process the data and what data to process. Now, when to process, meaning to say, is whether the data has to be processed immediately or later. Like some data needs real-time processing, for example, fire alarms, while other data can be processed later, for example, some daily reports. So choosing the right time will improve the performance. And coming to what to process is whether the data is important or it is normal. That is, not all the data is equally important. Critical data is processed first, while the less important data, it can be stored or analyzed later. Now, as we all know that all the data is not equally important and the critical data is processed first. So here, before deciding upon the processing to pursue, we must first divide the data to be processed into three types based on the urgency of processing. So first one is the very critical time data. So here, this data must be processed instantly without any delay, and it is used in emergency situations like fire alarms or heart monitoring, where even a small delay can be dangerous. Second is the time critical, that is time critical data that is of moderate urgency, and this data requires quick processing but not necessarily in real time. And a short delay is acceptable here, such as traffic updates or industrial monitoring systems. And the last one is the normal data, which is of low urgency. It means that the data does not need immediate attention and it can be processed later. So it is mainly used for analysis, reports, and long-term decision making like daily usage statistics. Okay. Now we will see the first type of data, that is the very time critical data, which requires the immediate processing. So here it needs instant decisions, meaning to say here is this type of data must be processed immediately as soon as it is generated. And there is no time for delay because the system must reach in real time in order to prevent the danger. And here the processing delay allowed is of few milliseconds, because only a very tiny delay is acceptable in processing here. and even a small delay beyond this can lead to incorrect or unsafe behavior. Some examples are the flight control systems, where the aircraft system continuously process the sensor data in order to maintain the stability, and any delay can affect control and lead to serious accidents. Then second is the health monitoring, where we measure the heart rate in and also it is used in ICU systems. So here the patient data like heart rate, then you have oxygen levels, then these must be monitored in real time, and immediate alerts are needed in order to save the lives during the emergencies. Then third is the industrial safety systems, where the machines in industries must detect the faults or the hazards, okay, instantly, and quick processing will help to prevent the accidents and protect the workers. Now, why immediate processing? Like, why we have to do the processing very immediately? Here, if processing is delayed, then if there are delays in handling the critical data, it can lead to dangerous consequences, and the system may fail to respond in time during the emergencies. For example, you may have aircraft accidents which may occur because of the late decisions in the flight systems, and even because of this, the aircraft may cause the loss of control, and this will increase the risk of crashes or unsafe landings. And second is patients' lives may be at risk. That is, in healthcare, delayed alerts can stop timely treatment, and this can worsen the conditions or even lead to loss of life. Next is the processing location, that is where it has to be done. Now, this has to be done near the data source, that is the edge or fog computing, where the processing is performed close to where the data is generated. And this will avoid sending the data far away to the cloud servers. And even this will reduce the delay, and it will increase the reliability, because the nearby processing minimizes the communication time, that is the latency, and it also ensures the system works even if the internet connectivity is weak. Okay, so this is about the very time critical system. Next is time critical data. So this is of moderate urgency. Now it requires processing quickly but not instantly, and also the processing is delayed processing is allowed here. That is of it may vary up to few seconds. And examples are the smart vehicles, where the vehicle data like speed, distance, and if there are any obstacles, these are processed very quickly but not instantly. Then you have traffic monitoring, where traffic data is analyzed in few seconds in order to manage the flow and reduce congestion. You have smartphones, homes, where the devices send the data like temperature, light, security, and these will receive the commands. Next, you have surveillance systems, where the video and the event data is processed after a short delay for analysis and alerts. And last is the industrial machines, where the machine data like vibration, temperature, then output, these are processed very quickly to optimize the performance. Now, why this remote processing is possible? Because a small delay is acceptable here, and the data can be sent to the servers or the remote processors. And the processing location here will be a cloud computing, where the data is sent to the cloud servers for storage, analysis, and the decision making. And also because of the collaborative processing, where the data is shared and processed across multiple devices or the servers for better efficiency. And here the key idea is not every data needs instant processing. Some data can wait for few seconds, and so we can use the remote or the cloud systems in order to handle it efficiently. Next comes the normal data, which is of low urgency. So here it is data that is not time sensitive, and it can be processed with a delay. So here as we know that the processing is not urgent, and the processing delay allowed here, it varies from minutes to hours. And examples are the agriculture monitoring, you have environmental data, weather tracking, soil moisture monitoring. These all are the examples of where the data will be of low urgency. And here the processing is slow, and this slow processing is okay because no immediate action is required and the data is mainly used for analysis and planning. And the processing locations here are the cloud servers and the centralized databases. So here the normal data, it helps us understand the trends and make better decisions for a better tomorrow. This is the summary table. Here we have taken the parameters as data type, processing time, examples, and the processing locations. And these are the three types of data. Very time critical data. Here the processing time is in milliseconds, whereas examples are healthcare, flight control, and processing location is edge or near the source. In time critical, processing time will vary from few seconds and examples are traffic, vehicles, smart homes. Processing location is the cloud or the remote. Then you have the normal data where the processing time varies from minutes to hours. Examples are agriculture and environment, and processing location is cloud. Now here we'll see just example, that is IoT in smart city. This is a simple example to make you understand real time example. So here different IoT applications require different processing speeds. So you have first one is the ambulance patient. Okay, here this is a type of very time critical data, and even a millisecond is very important here in order to save the life. So here it must be nearer to the edge or the near to the source, that is the processing location, and the alerts will be sent to the hospital systems. Then you have traffic signals where the processing location is nearer to the cloud or the remote server, and the time varies. Will be in seconds. Here it is in milliseconds, here it is in seconds. So example is a traffic management system in order to optimize the traffic flow. So this is the time critical data where the time will be in seconds. And here example is to reduce the congestion, that is the traffic congestion. Next is the crop monitoring where the processing location is the cloud or the remote server, and the time varies from minutes to hours. And example here, it can be used in the data which is there in the agriculture analytics, where insights and reports will be produced, and it is a kind of normal data. So example is in order to improve the yield. So here the key takeaway here is IoT applications generate the data with different urgencies, and matching the right processing speed ensures faster response, efficiency, and better outcomes. So the IoT is not only about collecting the data, it is also about processing the right data at the right time and in the right place. So efficient processing helps in faster decision making, then reduced network load and better system performance, and also improved safety and automation. So this was about the importance of processing the data in the IoT. Thank you.